All right, this is the third section in this chapter that is for HLs only. So if you're SL, feel free to stop this video now. HLs, we're going to talk about integration by parts. And to explain what that is, we need to go back and look at the product rule for finding derivatives. You remember that if I'm taking the derivative of two functions that are multiplied together, I'm calling those functions u and v. If I take the derivative of that, then I have to take the derivative of the first one, multiply that by the second one, and then add on the first one times the derivative of the second one. All right. Now, if I take the antiderivative of all of that, taking the antiderivative of each term, this is what it looks like. Just with a funky s and a dx at the end of each one. Notice how the dx's cancel, and I'm left with uv equals the antiderivative of v du plus the antiderivative of u dv. All right, and if I rearrange that and solve for the antiderivative of u dv, that will equal uv minus the antiderivative of v du. So the way I'm going to use this is I'm going to have an antiderivative that has two functions multiplied together. One of them is just a function, and one of them is the derivative of another function. And as you can see, at some point I'm going to have to figure out what the derivative of this function is, and I'm going to have to figure out what the antiderivative of this function is. So what you want to do is you want to pick which part of it is u and which part of it is dv. And the way to do that is to pick the function that is easiest to find the antiderivative of. That's the one that's going to be your dv. So there's a little acronym that you can follow to figure that out. So we're figuring out which part will be u, which part will be dv. This is all stuff that I just finished saying. All right. So when you're figuring out dv, the first thing you're going to want to find is an exponential. If you can find an exponential in your question, then that will be the dv part. If you can't find that, then you're going to look for a trigonometric function. If you can't find that, then you're going to find an algebraic function, which is any polynomial function, and that will be your dv. If you can't find any of those, then look for an inverse trigonometric, and if you can't find any of those, then you'll find a logarithmic, and that pretty much covers all of the functions that you could possibly have. Now, the way to remember this order is to look at the first letters of what I wrote down, and it spells out detail. Okay, so when you're finding dv, just follow detail, follow that order. All right, so let's do an example. We have the antiderivative of x times the cosine of x. So if I follow detail, I'm looking for an exponential first, and I don't see that, and then I'm looking for a trigonometric. I do have that. That is cosine x. So that's what my dv is going to be, meaning that the other part, this x, is going to be my u. Okay? So I figure out, once I have my dv and my u, from dv I figure out what the antiderivative of that is, and I call that v. Once I have what u is equal to, I find the derivative of that, and that's going to be my du. Then I simply rewrite this rule that was on the end of the first slide. The antiderivative of u dv is equal to uv minus the antiderivative of v du. And I simply plug in all those things now that I have all four. So the left side will look like my question, and I will simplify the right side to get my answer. Notice how uv doesn't have a funky s in front of it, so I don't need to find the antiderivative of that. That's fine the way it is. The only thing I need to find the antiderivative of is this sine x. Well, I know the antiderivative of sine x is negative cosine x, so that means this is my answer right here, x sine x plus cosine x plus c. And just to check to make sure that your answer is right, you might want to take the derivative of that and see if you get back to the question that we had. All right. In this example, I'm taking the antiderivative of natural log of x. Well, following detail, I have no exponentials, I have no trigonometric, but I do have an algebraic, and it's hard to find, but this dx is like 1 dx, so that's going to be my dv. making v equal to x. The other part is going to be my logarithm function. That's going to be my u, so that du is 1 over x dx. Okay, and just like before, I copy down this rule that was at the end of the first slide, and I make substitutions. Again, the left side is going to look just like my question, and the right side is going to be how I figure out the answer. X times the natural log of x is fine because there's no antiderivative sign in front. I just have to figure out the antiderivative of x times 1 over x once I simplify it. Well, x times 1 over x is just 1, so I need the antiderivative of 1, and that's just x. So my answer is x times the natural log of x minus x plus c. So those are 2 examples of doing integration by parts. If you have any questions, let me know, and I will see you tomorrow.